Menger-Diaz Fractals. I am Manuel Diaz, a mathematician, math teacher and artist from Lugo, Spain. Combining Menger's algorithm with Diaz's algorithms, initial atom, cube of existence, sizes of the cubes, we can get an infinite number of variants of the Menger-Diaz fractals. We will see 4 examples in 4 videos, but many more can be built. Imagine a Rubik's Cube compound by 3 to the power of 3 cubes. Then the edges has n equals 3 divisions. But if Rubik's Cube has n subdivisions on each edge, n number of subdivisions on each edge of a cube, resulting that each cube is divided into n cubed cubes. D, distance factor, depending on the size of the initial cube, d equals s, n2. In other polyhedra it can vary. Cube of existence, list of n cubed values 0 or 1 that indicate if in that 3-dimensional position we will have a whole or a cube. L, iteration level. The brick or atom initial. The more detailed explanation was made in the paper section. Example 1 Menger sponge with cube of stellar octangular. Menger sponge but with stellar octangular, changing the atom. The Sierpinski tetrahedron is one of the best-known fractals. It is not possible to do it with the Menger algorithm, but it can be done with the Menger-Diaz algorithm, with the parameters n equals 2, d equals 30, and we repeat the algorithm from L equals 1 to L equals 5, up to iteration level 5. Sierpinski tetrahedron, which is also a Menger-Diaz fractal, exchange cube for octahedron, cube of existence of size 2.